Okay, so 2021 Specialist Maths 2 multiple choice up to question 8 here. Euler's method with a step size used to approximate this differential equation given that y is 2 and x is 1. Find correct to 3 decimal places when x is 1.2. All right, so you're going to need to probably get your calculator to help you. Now, Euler's method is on the formula sheet on page 4 in the calculus section. So let's have a look. So x0 is 1. So x1, because we're using a step size of 0.1, is 1 plus that, so 1.1. Then x2 would be 1.2, and that's as far as we know we want to go because x is 1.2. So the y then. So y0 is 2. All right, Euler says then that the next y1, would be this 2 plus the step size times the derivative where are we? Let's see what I've got written down. Times 2 sine of 1. Now, where does the 2 come from? So that's y there, y naught. The 2 sine x naught. All right, and when you get calculator and do that, you get 2.168. Then y2 would be our 2.168 plus our step size times 2.168 times sine 1.1. And then we get our calculator out and do that, and then in your calculator you get 2.36153. All right, so we're looking at which one is closest to that, to 3 decimal places. So that's 2.362 to 3 decimal places. Alternative C. All right. So Euler's, as I said, method, it's on the formula sheet. All right. Next, which one of the following derivatives correspond to a graph that has no points of inflection? No points of inflection. So it could have turning points, but it can't have points of inflection. So what we need to do is we need to see what's going on with the second derivative. Because if there's no points of inflection, the second derivative will always be either positive or always be negative. All right, so we need to have a look and see what the second derivative is. So the second derivative of this one, when we do it, the 2 comes down, multiplies by that 2 that's already there, and so you get 4x minus 3. And 4x minus 3, depending on what x is, can be positive or negative. Can be. All right, let's have a look at this next one then. So f double dash is of x, 3 2's, 3 comes down, 3 2's 6, x minus 3, that reduces the power, is squared. Now, this one here, because we've got this squared, we know that this one is always positive. So the graph is always increasing. So if it's always increasing in its gradient, then we're not going to have a point of inflection. All right. So B is our alternative. All right, so there's that one. All right, next one that we've got, question 10. All right, question 10 is a calculator question. So find the differential equation that has this direction field. So you need to get your calculator and use your calculator on this one. So let's see how we go here with this and see whether I can get the calculator to work on the screen. So to do that, I need to go to the menu. And there's the menu, and I go to the diff equation screen. Now I've got something in there that's not what I want. Now a handy thing is with this is to have your calculator screen the same domain and range as that. All right, and see this one, whatever I had on previously, and I want to go here, and I want it. I need to put one in first. So I need to. So what I'm going to do is here's just simply trial and error. All right, and so we've got y plus 2x. All right. Oops, too many pluses there. Plus 2x. And I'm going to graph that. All right. Now, it doesn't look like it, but as I said, it's more difficult here to visualize if your calculator screen is a different size to the one. All right, and so now when we look at that and we can compare and we can see that that's not the same. So if you then work your way through it, and then when you get to alternative D is y minus 2x, and then you graph alternative D, and you can see now when you compare your computer screen to the one on your calculator, you can see that now looks quite like it. So alternative D looks a bit different because of the number of arrows that I've got. So if I was to go, keep trying to do it on the computer screen, I'll get to do it on my calculator. If we want the number of steps, if we want to, do that like 25 steps, for example. All right, and then there you go. That now looks a bit more like it. All right. Okay, so back to our thing here. So alternative D is the one we are looking for. All right, so the best way of doing those types of questions is exactly how I've done it there, to use your calculator to graph it and then compare your screens. Make sure you put your window the same as whatever these are. All right, I think that might do us for this video. Next, question 11 on another video.